All right, welcome back, everybody. Here we are, Savas Algebra 2, lesson 7-3, the second problem I've asked you to do. Find the exact values of the 6 trigonometric functions of the given angle. So 420 degrees, 420 degrees. There's our little unit circle. 420, we're rotating in a positive direction. So 420, there's 180. Second time around, add another 180 to it. We're up to 360. Next time around, add another 180 to it, and we would be at, where is that? 540. And we just went past it. So the second one, we're not that far. So let's take our 420 and take our 360. We only needed 420. We were up to 540 if we did 3 rotations around there. So let's see. We need, after our 360, 60 more degrees. So that means after we went around twice, 2 revolutions there, we need another 60 degrees. So our terminal's angle right there was the reference angle 60, right here, down here with the angle made with the x-axis. So 60 degrees, and we're talking about the sine. So if you remember, we're talking the unit circle. We use this so that we could get answers quickly. Just sort of quick review there. 60 degrees. If we use the 1 there, right angle down here, just drawing that triangle. So then how we developed that, if you recall, we said if we had another 30, 60, 90 over here, all the sides would be the same. So this whole side down here, if you use the whole thing, would also be 1, because 60, 60, 60, equilateral, equiangular. And then when you split that because of the symmetry, or you could prove it in geometry, the hypotenuse leg theorem, because you have the hypotenuse here, the same as this length here, and you've got that leg, right? Anyway, congruent triangles, I like to just make sense that that would have to be symmetry that's involved. Half, and then we did the Pythagorean theorem, half squared plus the missing legs squared equal to 1 squared on the hypotenuse. If we were just looking at the triangle on the left, the original, and a half times a half is 1/4. And our b squared being 1 squared, subtract the 1/4 over to the other side, that would give us 3/4, 1 minus 1/4. So we've got our b squared being that, and then we're going to square root both sides. And you will end up with your square root of 3 over your 4, square root of 4 being 2. So this side right here, on our unit circle, whenever we're doing any of these 30, 60, 90 triangles, we've got a half on the short leg. We've got a square root of 3 over 2, and then we'll always have 1, because no matter where it's drawn, your hypotenuse will be the 1 on the unit circle. So back to our problem, sine of the 420. Sine, if you remember, opposite over the hypotenuse on these problems. So the opposite side is the y side. So we're going to end up with the y over 1, or we also always said that sine is going to be the y side. So over the hypotenuse, the 1. So opposite over hypotenuse for sine, opposite square root of 3 over 2. We're using the 1 unit circle, hypotenuse always 1. So square root of 3 over 2. And let's see if after all that, so a lot of review explanation there again, just so if sometimes I'm not sure I could do it quickly, but I'm not sure if you would remember where all of the parts were coming from. So we need a fraction. I need a square root in the numerator with a 3. And down in the denominator, I need a 2. And that's what we're after. So hopefully that helps. And then the second part of the problem, select the correct choice below. So we want the cosine at that same angle. So remember, cosine is ka. So if you got your cosine now, Let's see. Adjacent over hypotenuse, and adjacent to my 60 degrees right here, the 1/2, hypotenuse 1. So just need the 1/2 in there, and we should be good to go. So let's put that on in there. Get the 1/2. Bada boom, bada bing. I think we will be on our way. So hopefully some of that explanation helps if you were stuck. Good luck. Wait, oh my goodness, we got lots more. Sorry, I thought we were done. Okay, now moving on to the tangent. Tangent, TOA, opposite over adjacent. So opposite over adjacent, TOA. So my opposite side was the square root of 3 over 2 over adjacent. Next to it again was that 1/2 for cosine. I'm gonna, instead of dividing by the fractions, multiplied by the reciprocal, just write it up here. So instead of 1 over 2, flip-flop, bring it to the top is 2 over 1. Those 2's will cancel and leave me with the square root of 3 there for my tangent. So square root of 3 in here. There's my square root. Button right at the bottom. So my square root of 3. All right. Now, moving on from there, everything we already have, we should be now thinking about just the reciprocals of those. So the cosecant, remember when you do reciprocal functions, they always, a co matches up with a non-co. So we had sine and cosine and tangent. And then the obvious for tangent is cotangent. They just go together. Cosine then, secant, and sine with cosecant. So we're doing cosecant right now. So then cosecant, we'll go back to sine. If we went back to sine, that was the square root of 3 over 2. So we need the reciprocal, 2 over the square root of 3. And a reminder with that, no square roots in the denominator. They rationalize the denominator. The radicals, like a square root of 3, are not rational. So we get 2 square root of 3 over square root of 3 times square root of 3 is just a 3. So let's see how it likes that. 2 square root of 3 over 3. Need a fraction. I need a 2 and a square root and a 3 up there in the numerator. And on the bottom, a 3 in the denominator. And it likes that too. All right, I am getting too much stuff on the screen. Let's clear some of this off from here so I can see what we're doing. Getting lost in some of this stuff. Leave that triangle over there. I might talk about that again. If we need some of the other parts, we'll move up on the page, look up something to see what it was, and then we'll do the reciprocals. So we now are on the next problem is the secant. So secant's reciprocal with cosine, as I just showed you moments ago. So secant reciprocal is a non-co, or is a cosine, a co. So the only other co is cosine. Secant does not go with cosecant. So we had the cosine, remember, was a 1/2. So if we do the reciprocal there for secant, it's going to be 2. Flip over the 1/2 and a little old 2 in there. That should take care of that one. Get that 2 in there. And we should be closing in on them here. Last one for the cotangent. We just need to flip over the tangent. Remember, tangent up above there. Up above, what was the tangent? Tangent was a square root of 3. And if you remember, now let's just work it out. So a square root of 3 for tangent, which was correct, which is like square root of 3 over 1. So cotangent, if we flip that over, it'll be 1 over the square root of 3. Again, rationalize the denominator. Some people will say that's not necessary, but oftentimes it is. So let's make sure that you know how to do it. And square root of 3, square times square root of 3 in the denominator, and then so square root of 3 over a 3 for our final answer on that one, and then we can move on to the next problem. All right, hopefully that's helping you out a little bit. Square root of 3 over 3, that's a fraction, my square root of 3 in the numerator, and a 3 in the denominator, and we have it. So again, hopefully some of that helps you if you were having trouble with any of those. And we'll get on to the next problem. So stick with it, just don't give up. Look up trig functions, unit circle, degree rotations, if you're looking for extra resources, and whatever you do, stick with it, determination, you can get it.